Welcome to Brain Vision.
So in this problem, we have to find out the value of the current which is flowing through the branch IAA, and this is our N, and this is capital N. So the current through INN and the current through IBB. So let's apply the mesh analysis. So if we apply the mesh analysis, and this is the current I1 which is flowing in this loop, and this I2 which is flowing in the given loop. So what I can write is, with the help of mesh analysis, the equation for the mesh one will be 120 is equal to, this is our 120 source volt, is equal to the total impedance in this loop will be 24. This is 24 minus 2 plus 1, and this plus 1, so this will become 26 minus 2j with the multiplication of current I1 minus I2. Similarly, for the loop 2, the loop equation will be 120 is equal to 17 plus 4j into I2 minus I1. As you can see, the current, this is the, if you look at the loop 1, the current I1 in this direction and the current I2 in this direction. So the difference of both of them will come over here, which is I1 minus I2. Similarly, for the second loop, the current of the I2 is in this direction and the current of I1 in this direction. So the difference will come over here. Similarly, if you look at the loop 2, the total impedance, which is 15 plus 4j, and then this 1 ohm, real 1 ohm, and this is also the real 1 ohm, so this will become 2. So the final value will become 17 plus 4j, which is given over here. So in this way we will get the two equations in I1 and I2, and first we will try to find out the value of I1 and I2, right? So let's erase it. So this is our, this is these two are our final equation for mesh 1 and mesh 2, right? So now what I'm going to do is, I'm going to solve these two equations, simultaneous equation, with the help of matrix analysis. So if we write a matrix, what I can do is, I will take a matrix. This is our 120 and 120. These two 120s are over here, which will become equal to 26 minus 2j. 26. I am writing the equation in I1 and I2, right? So if you isolate I1 and I2 from here, you will get these respective values. So this will become minus 1 and 17 plus 4j, right? And here what I will get is, this will get I1 and I2, right? So this is the matrix equation. Now what I have to do is, I have to solve these two simultaneous equation for I1 and I2. So you can use the MATLAB or another scientific calculator to calculate it. So what I'm going to do is, I'm just using the MATLAB and writing the values over here. So the delta for this analysis will become the 449 plus 70j, and the delta 1 will be 120 18 plus 4j. You can use the MATLAB or any other software, or any other calculator, right? So, or you can manually, you can also do. So this will become 120 27 minus 2j, right? These are the values of delta 1 and delta 2. So what I can say is, the value of I1 will be delta 1 by delta, right? So the value of delta 1, which I have calculated, I have to put it over here. So what I'm going to do is, I'm just putting the value. This will become 120 multiplied with 18.44 angle 12.53 degrees, right? I just convert it into the polar form, and then this will be value of the delta. What I have to do is, I have just convert these in the polar form with the help of calculator, right? And just putting over here. So the value of delta is 444.42 angle 8.86 degrees. So the final value of I1 will become, so the value of I1 which I will get is 8.4.87 angle 3.67 degrees. Similarly, if I calculate for I2, so what I can write is, the I2 will be delta 2 by delta, and to put the value of delta 2 in the polar form, the value will be 120 into 27.07 angle minus 4.24 degrees over 454.42 angle 8.86, and the final value is I2 is equal to 7.15 angle 13.1 degrees. So we have to find out the value of the current through IAA and IBB. So the value of IAA is equal to I1. Similarly, the value of IBB is equal to minus of I2. So we have find out the value of I1, which is equal to 4.87 angle 3.67 degrees. So the value of IAA will be 4.87 angle 3.67 degrees, and for the value of I2 is 7.15 angle minus 13.1 degrees, and I have to get the value of I2. So what I will do is I will add 180 degrees to get the value of minus I2. So the final value of IBB will become, this is capital B, the final value of IBB will be 7.15 angle 166.9 degrees. So this is the value of IBB. This is the value of IAA. Now the final value of I and N can be written as value of I and N will be the value of I and N is equal to I2 minus I1, and the I2 minus I1 will become 2.856 angle minus 42.55 degrees ampere. This is the final answer of I and N.